Reciprocity theorem. Reciprocity theorem states that in any linear bilateral network, if a single voltage VA in a branch A produces a current IB in branch B, then if the voltage source VA is removed and inserted in branch B, will produce a current IB in branch A. The ratio of response to the excitation is same for the two conditions mentioned above. So, I'm having a network having two branches in B. If I have a voltage VA which produces a current IB, we can interchange the branches. So even interchange a VA to here and IB to here. In this network also getting the same current as we get in this network. The ratio of responses to excitation is same for the two conditions mentioned above, which is nothing but in this case 1, response is IB, excitation is VB. So VA by IB. In the case 2, the response is IB due to the voltage VA. So here VA by IB. Both are same. This is our network having 20 volt source across the terminals A dash, and we need to find out the response between B dash across the 2 ohms. So first let us try to find out the current through this branch B dash. The current through the 2 ohms is given by the total current multiplied by parallel branch resistance divided by the parallel branch resistance plus 2 ohms. Finding the total current, first we need to find out the total resistance, that is R total is given by 2 ohms plus 3 in parallel with 2 plus 2 in parallel with 2. This value is 1, so this total value is 3, and 3 is in parallel, so 9 by 6 is nothing but 3 by 2 plus 2. 3 by 2 is nothing but 1.5, this is total value, plus 2, that is 3.5 ohms. Now the total current IT is given by 20 volts divided by 3.5, which is nothing but 5.71 amps. Now the current through the branch B is equals to, if you find, then 1.43 amps. After replacing these branches, take this branch to here and this branch to here. The network will be now in this case the current IA we need to find out. Then the same formula we can use. Now the total resistance RT for the case 2 is equals to 2 and 3 in parallel plus 2. This total value is again parallel with 2 plus 2. Then you are going to get 3.23 ohms. Now the current through IA, that is 1.43 amps only. In both the cases, the source or excitation is 20 volts and the response is 1.43 amps in branch of 2 ohms. Hence the reciprocity theorem. Compensation theorem. Compensation theorem states that any linear bilateral network may be replaced by a voltage source of the magnitude equal to the current passing through the element multiplied by the value of the element, provided the currents and voltages in other parts of the network remains unaltered. So if we have a network having the resistance R, the current flowing through it is I, then this can be replaced by a network with V equals to IR. And this theorem is also useful in finding the changes in the currents or voltages when the value of the resistance is changed in the circuit. Let us consider this network. This resistance is changed. This is R and this is delta R, high current flowing through it. Then this change in the resistance causes a change in the current in all the branches. This current increment in the other branches is equal to the current provided by the voltage source of the voltage I delta R. Provided by the voltage source of the voltage I delta R, which is replaced in series with the altered resistance as shown in this network. Now determine the current flowing through An ammeter having 1 ohm internal resistance connected in series with the 3 ohm resistor, and this is our given network or circuit. Let us find out the current flowing through 3 ohm resistor. The current through 3 ohm resistor is given by the total current and the opposite branch resistance divided by opposite branch resistance plus the branch resistance. Then the total current IT is equals to the voltage divided by the total resistance, that is 4 plus 6 and 3, that is 6 into 3 divided by 6 plus 3, that is 9. 10 by 6, which equals to 1.11 amps. Since an ammeter is connected in this network, one more changes in the currents in the other branches, then results as if a voltage source of I delta R volts is acting in this branch. Then this value is given by the current, that is 1.11 in the branch multiplied by the ammeter resistance, this, that equal to 1.11 volts is here. Now let us find out the current flowing through this branch. Then the circuit, this is 1.11 volt, this is 4 volts total with a meter, and this is 6 volts, and this is 4 volts. 4 in parallel 6 plus 4, that is 4 into 6 by 10 plus 4, which is nothing but 6.4 ohms. Now the total current through this is given by 1.11 by 6.4, which is nothing but 0.17 amps. This current is opposite to the current I3 which we found here. So the difference is going to be measured by the ammeter. So the difference in the currents is equals to 1.11 minus 0.17, which is nothing but 0.94 amps. And this is the current measured by the ammeter, which is in series with the 3 ohm resistor.